Double slit interference. Double slit interference, if you have a wall with two holes and you have interference coming through, this is sort of what the pattern you would expect. So the green spots are going to be constructive interference spots and the red spots are going to be destructive interference spots. So interference, say there are some preconditions for interference patterns to happen. One is light must be monochromatic. Basically, that means is it involves only a single frequency and a single wavelength. Light sources must be coherent. That means the relative phase will also always be the same. And the light sources must have the same amplitudes. If these conditions do not hold, one still gets constructive and destructive interference, but the interference patterns can change with time or not be complete. Destructive interference leads to a decrease in amplitude, but not to zero amplitude. Now, in two slit interferences, a coherent light source illuminates the first slit. This creates a nearly uniform but coherent illumination of the second screen. From one side of the screen, the light wave has the same oscillating phase. If two waves from the two slits S1 and S2 create a pattern on the third screen, what we see is that it is a pattern of light and dark alternating fringes on the third screen. So the light visible from the two slits form a visible pattern on the screen. This pattern consists of a series of bright and dark parallel bands called fringes. Constructive interference is where the bright fringe was, and the destructive interference was where the dark fringe is seen. Here's a really good depiction of what actually is going on. So if the two waves coming in are exactly reaching the spot in phase with each other, we will get constructive interference and a bright light. If the two waves are off from each other, and you will see destructive interference, right? Destructive interference will give you a dark spot on the screen. So let's talk about constructive interference, figure B first. So the lower wave has to travel further than the upper wave. The lower wave is one wavelength further. Therefore, the waves arrive in phase with each other and a bright fringe will occur. Now, if the two waves are half a wavelength away from each other, that means then they reach that particular point here, they're exactly out of phase with one another. And at that point, we will get destructive interference. Now, Young's double slit interference experiment was a very, very good experiment for proving the wave nature of light. It was carried out in 1801, and what he did was that he had some incident waves hitting a beam screen 0. Then those wave patterns will hit the screen S2 and S1, and those then hit the screen, and you will see portions of dark and light on the screen as we were seeing before. And double slit interference patterns look like this, going outwards. Constructive interferences are given by light, again, the bright spots, and the destructive interferences are given by the dark spots. Now for some math. So for a double slit interference for bright fringes, you will get lambda L over dm, where m could be 0, plus minus 1, plus minus 2, and so on. For dark fringes, you will get lambda L over d m plus a half, where m is called the order of the interference fringe. Intensity of a double slit pattern. For more detailed exact value of the intensity of the double slit experiment is given by I equals I max cosine theta pi d sine theta over d. Now, we're not going to get into the details of how this formula came about, but you should probably remember this for the homeworks and the exams. Another really important aspect are called Newton's rings. Newton rings basically consist of a piece of glass and a flat piece of glass together, and when you see it from the top, you will see patterns are circular. This is very similar to what is going on in the Young's modulus, but you will get different colors depending on where the light is actually coming from.